Hello, tell me students if my voice is clear to all of you. Hello, hello, hello. Now is it fine? Hello, wait a second. Hello, there is some glitch that is coming. Hello, 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 hello. Now is my voice is clear? Now is my voice is clear? Hello, 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 hello.
हाँ वेरिफिकेशन वेरिफिकेशन लाइव नहीं होना अभी
Hello, hello, hello. Is my voice is clear now? Is my voice is clear? Okay, fine. Let's start.
You were listening to that because you are playing it on your phone also and it is bouncing from the mic in the phone. That is why that sharp sound. That is why that sharp sound.
So fine. Let's begin. Okay. Namaskar, Adab, Sat Sri Akal. Welcome back, students, to one more lecture of our marathon series, marathon revision series that we are having. Okay, if still any problem will be coming in the voice, then please tell me in the between. Okay, we'll check it. Otherwise, let's continue. So today, what the topic that we are going to discuss in this marathon revision session is center of mass. Now, a lot of students have very fear of center of mass, but it is not that much of typical topic. If we will break it down, the first portion majorly talk about how to find the center of mass. In middle portion, we study about conservation of momentum, also how momentum can be conserved if there is no external force. What I can say that if initially center of mass is at rest, finally also it will be at rest simply. At the end, what we do study in this chapter, at the end of this chapter, we used to study about different cases of collisions. You know that how many kind of collisions are there. All these things are we are going to discuss in this lecture. For regular bodies, for irregular bodies, like for different shapes, we are going to discuss how to calculate the center of mass. All these things are what we are going to discuss in this topic. Is it clear? So let's begin without wasting further any time. So fine, let's start. Center of mass. From the name itself, what to understand? Center of mass. Okay. So I think that you have the basic idea of center of mass. Center of mass is an imaginary point. Basically, you can say for analyzing a complete system, we have created for our convenience, we have created a point, yet imaginary point in the body itself. It is not necessary that it will always be in the body. When there are multiple bodies, it can be in somewhere in between them also. You know that when I am talking about a single ball, the center of mass will be lying exactly at the center. But when I am talking about two identical balls, then center of mass is not lying on any one of the body, then center of mass is lying at the center, if identical balls I am talking about. So what is the center of mass? Center of mass is basically an imaginary point where you can assume that all the masses are concentrated, where you can imagine all the masses are concentrated, correct? For example, see here, this is m1, this is m2, two masses are there, identical masses, so center of mass will be lying exactly at the midway between them, correct? Why it was lying exactly in midway between them? Because both the masses were identical. Second scenario, one mass m1 is looking so heavy and m2 mass is looking so light. So where the center of mass will be lying? Now is it lying in the center part? No, not exactly. It will not lie on the center part because it gives you idea about where the majority of the masses are concentrated, correct? So if I can say that majority of the masses is concentrated on the m1 side, can I say center of mass initially was lying at the center point distance, but now it will be shifted towards what? It will be shifted towards m1. And why we have created the concept of center of mass? To analyze the motion properly. Now if there are four body, they are performing some motion, we can assume their center of mass and we can only write the equation for the center of mass that will be representing all those four masses. So it becomes convenient for us to analyze the system if we have to apply, let's suppose mg force. Let's suppose there is a rod, there is a complete rod, and you want to draw the mg force direction. How you will be drawing? Correct? You have to represent the center of mass. Always remember that mg force is always acting at the center of mass. So this is the convenience that we get from center of mass. Okay, so this was the basic outline about the chapter. Now let's enter into the first topic, how to calculate center of masses. What is the formula? I hope that all of you are familiar with the formula. Okay, see here is the use given for center of mass. Let's suppose here for this most better example, that let's suppose is that it's a car. Can you say it is made up of number of particles? It is made up of number of particles. So I can say, if I am talking about the front portion of the car, that means it is moving with some velocity, and some back portion it will have some different velocity. Velocity will be same, but the displacement at every single point will be different for both this point. Obviously it will be different, correct? So let's suppose if I have to analyze in general about the car, will I analyze for every single point differently, or at a one time? If I have to discuss anything about the car, that if this car is going to overtake a truck or whatever it is going to do, I am going to analyze for the front portion only. I am going to analyze for the driver's seat portion only, or I am going to discuss about the last portion of the car only, or either I am going to discuss about the whole as a whole, this car as a whole. So I am going to discuss it as a whole. So for that, what I have to do, I have to assume at the numerous points, I have to assume that a center of mass point that will be representing that all of the mass is concentrated at the single point, and now I will be representing that single point as a complete whole, and I am going to write all the equations of displacement, velocity, acceleration, and everything for that single point, and that point is what? Center of mass. This is the use of center of mass. Okay, I hope that my voice is clear. For that single point. Okay, fine, very good. So this was the use of center of mass. Now let's suppose how to write the center of mass. How we'll be writing if in the let's suppose n number of masses are distributed into the system x, y, z. I am talking about in general. So how we'll be writing the center of mass? See, let's suppose mass m1 is present here, some mass m is here, m2 is here, let's suppose some m3 is here, let's suppose some n number of mass is here, let's suppose this is m3. Okay, so you have to calculate center of mass, and what are these r that are represented? These are the position vector. I guess now you all are very well know about position vector. So what is the formula that we get for center of mass? RCM. In general, position for center of mass is m1 r1. Simply multiply the center of mass, the position vector with mass, plus m2 r2 plus m3 r3 plus rcm into m center of mass divided by the total mass, that is m1 plus m2 plus m3 and so on till mn. This is what you can say for the position of center of mass. This is what you can say for the position of center of mass. Okay, fine. Now it's up to you. Let's suppose now the position vectors are given. Position vector in terms of x cap, y cap and j cap are given. Then how you can calculate the center of mass? Again, you can write the formula of m1 r1 plus m2 r2 plus m3 r3. There is no problem, but you can split this question also in finding the position of center of mass of only x coordinate. In x coordinate, where the position of center of mass is going to come, then you can split it into y coordinate, where the y coordinate center of mass will be coming. Then you can separate this question into z coordinate as well, that in z coordinate what will be the center of mass, correct? This way you can analyze the question. For example, here all the position vector in terms of x, y, z, z is given. So how you will be writing differently? Firstly, you will be writing xcm. How you will be writing xcm? Last time you have written the in general position vector. This time how you will be writing? m1 x1 plus m2 x2 plus m3 x3 and so on, divided by the total mass, that is m1 plus m2 plus of m3. This is what you have to write, position of center of mass, correct? Same way you can write for ycm, m1 y1 plus m2 y2 divided by the total mass. Same you can write for z center of mass. So this way I can say you can find the all three coordinates of the center of mass in x direction also, in y direction also, as well in z direction also, correct? Very good. So if you are able to understand this much of the thing, now let's come to a basic question and let's try to apply the formula into this question. See, what is the question? Two bodies of mass 1 kg and 3 kgs are given, have position vectors of I plus 2 plus k and minus 3i minus 2j plus of k respectively. The center of mass of the system has position vector. You have to calculate what will be the position vector of the center of mass. So let's see how you can calculate. See how you can calculate. For 1 kg of body, the position vector is I plus 2j plus of k. For 3 kg of body, what is the position vector? For 3 kg of body, minus of 3i minus of 2j plus of k, correct? So now how you can write the position vector? R center of mass, position vector, how you will be writing m1 r1 plus m2 r2 divided by m1 plus m2. This is what our formula was, correct? So now just put the values into our formula. Let's see what is the result will be coming. Let's cross check it. m1, what is your mass? 1. What is the position vector? I plus 2j plus of k plus. Now what is the second mass? 3. Now what is the position vector? 2 minus of 3i minus of 2j plus of k divided by, what is the total mass? You can say total mass, I can say it is 4, correct? Now calculate it and tell what is the answer coming. Just check what will be the answer. Here I am writing this NEET 2009 question as well. Okay, see, I minus of 9, that means what I can say, it will be minus of 8i, correct? Here then what you can say, further 2j minus of 6j, 2j minus of 6j, that means I can say minus of 4j, correct? K, then it will be here plus of 3k, that means I can say it is plus of 4k divided by the total mass, that is 4. That means what is the position of center of mass is coming, just divided by 4, it will be having minus of 2i minus of j plus of k. This is the thing that you will be getting, correct? Clear? समझ आया कैसे? Just we have checked the position vector, we have checked the masses, and then we have just put the values into the formula and we got the final result. Easy question. And this kind of questions you will be getting, you can expect. This was a NEET paper question. This kind of questions you can assume generally in NEET and CET exams, okay, in boards as well. Now let's suppose for continuous bodies where you have to use integration. Now every mass, it has different distances, so then how we can proceed? This was the fixed distance, okay, but let's suppose you are having a ball or having a pen, okay. So now where you define the center of mass? I guess most of you will be knowing the result, it lies exactly in the between, correct? But how to derive that? Because if I will take any position at reference point, I can say that this small portion of mass is a different distance, this small portion of mass is a different distance, this small portion of mass is a different distance. So I can say, so all the small portions are at different distance from this origin point, correct? That means I cannot write all of those, so I will take an element and then I will write the effect of all those small elements, and then I will integrate it for the complete rod or what kind of shape it is given. So I hope that in your normal lecture you have understood the derivations are important for good questions. Here we are going to see the overviews, how we can derive that in the good questions as well. Okay. So in general, how we write the formula? We write xcm if you want to calculate of the continuous body. How you will be writing? Xdm divided by integration of dm. Integration of dm is nothing but the total mass of the continuous body that you are taking. And xdm, how you will be writing? That we are going to understand. 1-2 derivations we are going to understand, and that will be sufficient for you to understand the complete thing. Same goes for y direction also. In y direction, in y axis, what is the position of center of mass? That you can get for y dm divided by integration dm, and z axis same, identical. Now let's suppose you want to integrate for this rod, okay, so that it is a continuous body, that means you have to use integration. Now how to apply? Formula already we know. One more thing I can say, divide it in x-axis, can you say center of mass will be lying only on the x-axis? Because the variation can come only on the x-axis. Otherwise for y-axis there is no change. For y-axis the center of mass is obviously lying on the same line, it is very sure. That means y position will be 0. That means I have to worry only for the one direction, x-axis, correct? So in x direction, what is the formula of center of mass? X dm, integration of x dm divided by m, correct? This is what our formula. So see how we write. Before that, I think that all of you would be knowing about lambda. Lambda is represented as mass per unit length. Is without using lambda also we can do the derivations, but still you should be knowing about it. Let's suppose somewhere this representation is there, so you should need to understand. So what we will do, we will go at a distance x from the origin point and we will cut an element of thickness dx. We'll cut an element of thickness dx, and we will be writing the effect of this dx element, and then we will integrate it for the complete rod. See, what is the formula? X into dm. So how I am going to write the x center of mass? Let's understand. The total mass is, let's suppose, given as m, so it will directly come in denominator as m. x into dm. How to write the dm mass, that is important. This dx thickness that you have cut it out of the rod, how to write the mass of that small element to write. Understand here, that is the most important thing. A lot of time I have told you that example of 5 students 10 chocolate, then 1 student how many chocolate, then 2 students how many chocolate, correct? That same thing. So I can say L length have mass how much, m. That means 1 unit will have mass how much, m by L. That means dx unit will have mass how much, that will be equals to m by L into dx. Dx unit will have mass how much, m by L into dx, correct? Fine. So now just put the dm mass here. It will be m by L into dx. This will be the dm mass. You have to integrate it from 0 to L. Can you say this position x is equals to 0, and can you say this position is x is equals to L, correct? So I have to integrate it for the complete rod. Very good. 1 by m. Integration will be now. Can you say this m will also get cancel out? What will be left? Remove this also. You can write directly 1 by L into integration of x dx, integration from 0 to L. So what is the integration of x dx? Can you say it will be nothing but x square by 2. Now put the limits. When you are putting the limits, it will be L square by 2. It will be L square by 2, and in division already there is L. This L is present here already. This L will get cancelled, and I can say the center of mass will be lying exactly at the L by 2. And we know that for a continuous body, let's suppose mass is uniformly distributed, exactly the position of center of mass is coming at the identical center point. That means at the halfway exactly the center of mass is lying, and our result is also giving the same thing. Clear how we can derive the things? Important is how to write the dm mass. Every time you have to be careful about writing the dm mass. Once you are able to write the dm mass, how to write the dm mass, then rest of the things are easier. Okay. See, L by 2 will be the distance. Now let's change the value of lambda. Here you will understand the value of lambda. What is the meaning of lambda? And let's do the division. This time value will be changing, because this time variation of mass is different. The distance is changing, with that the mass is also changing. That is the variation that is given here. At, let's suppose x is equal to 1, lambda value will be different. X is equal to 2, lambda value will be different, correct? That means mass is changing with the distance. It is not uniformly distributed mass. So for this kind of cases, what we can do, let's understand. Again we are going to follow the same process. See here, what is that process? We'll go at a distance x and we'll cut it out an element of thickness dx, and we will try to write the dm mass, small mass, because we know the formula that we are going to have for center of mass is integration of x dm divided by integration dm, correct? This is what we already know. So how we are going to do? See, lambda is defined as a into x. What is lambda? Lambda is equals to mass per unit length. Mass per unit length. So if I have to define dm mass, can you say it will be lambda into length, correct? And I want to write the mass, dm mass of this dx element. That means I can say the mass that I will be writing is lambda into dx. इतना समझ में आता है? आता है? Same. In it out, how will we write that dm mass? Dm mass simply how I can write mass per unit length is defined as lambda. That means mass I can write dm mass, I can write lambda into length of that element. So what is the length of that element? That is equals to dx. Simply I will multiply, correct? Now see, fine, xcm is like this. Now what you will be writing? X into dm mass. Dm you have already calculated, that is equals to lambda into dx, and divided by total mass is already, you can write dm mass as lambda into dx. Dm mass, how you can write integration of lambda into dx. Now see how further you can solve it. Now put the value of lambda, x into lambda x, x into lambda x, lambda value is given as a into x. So put the value a into x into dx. In denominator as well put the value ax into dx. After that it just left about solving. So solve it. In the numerator what you will be having, and the integrations will be from 0 to L, 0 to L. Fine. In numerator, this a constant will also get cancelled. In numerator, it is x square, that means it is the integration will going to give you x cube by 3. In denominator, it is x dx, that means this integration is going to give you x square by 2. This is the integration that we will be getting, and this x square x cube will get cancelled. That means what is the left answer? That is 12 by 3 when you put the limit. So this time you have noticed that center of mass is not lying exactly at the halfway. Center of mass is lying at the distance 12 by 3, because with the distance the density of mass is increasing. That's why this time it was not lying. If it is uniformly distributed body, that means at every single point equal mass is distributed, then the center of mass will be lying exactly at the halfway. Otherwise you can see it will be varying in different cases. समझ में आया? So this is the root of derivation of all those different shapes. Okay. For symmetry bodies, let's see for symmetry bodies what you can do. Symmetric bodies you can judge very easily. Let's suppose there is a ring. If there is a ring, what I can say, which point will be behaving like center of mass? Can I say exactly at the same the center point? Because I can say that all the points on this ring is having identical distance from the center. Let's suppose this is the shape. Next cubical shape is there. So the center point will be behaving like center of mass, because this is the identical point from where all the points will have the same distance. So these kind of symmetric bodies you can easily judge. Okay. Now let's see for this kind of body. Let's understand what is the question is saying. For identical single body you can easily say, but let's suppose I have combined two bodies. Let's read the question firstly and then understand what the question is actually asking me. Two identical uniform rods PQ and QR. Two identical rods are there. Each of length L and mass M are jointed to form a L-shaped body. Okay. Frame as shown in the figure. Locate the center of mass of the frame. The center of mass of uniform rod is at a middle point of the rod. Uniform mass, it is already given. For this uniform mass, the center of mass is lying exactly at the center. Okay. But for this combined body, what will be the center of mass position? This is what you have to calculate. So let's see how we can calculate that. Okay. Fine. So let's break this question into two portions. In x direction, what will be the direction of center of mass, and then we will calculate for y direction. So what is the formula that I am going to write for x center of mass? I am going to write m1 x1 plus m2 x2 divided by m1 plus m2. And for y direction, how I am going to write the formula? m1 y1 plus m2 y2 divided by m1 plus m2. Correct? Now let's see how we can solve. In x direction, now only focus. Let's suppose I am naming this body as m1 and I am naming this body as m2. These two bodies, let's suppose I am naming. So what I can say, m1 x1. What will be the position of x position of center of mass? Can you say position of center of mass will be lying exactly on the same rod? That means there is no difference in the position of center of mass, and I am assuming this is a reference point 0, 0. So can I say the position of center of mass for m1 will be 0? Because its x position of center of mass is exactly lying at the origin point, or the this x-axis, y-axis. Correct? Now for y direction, where the center of mass is going to be like, can I say the position of, this is the position of center of mass for this body, and I can say what is the position of this point? I will say simply 0, L by 2. Correct? So I will be writing here m2 into L by 2, m2 into L by 2 divided by total mass. Total mass, simply I will say it is equals to 2L. Because masses are identical bodies are given. So what will be your x position of center of mass you will be having? So this will become completely 0. This will get cancelled. Mm is there. So simply you will be having the result L by 4. Simply you will be having the result L by 4. Correct? Now come to the second one. In y direction, what is the center of mass you will be writing? M1 y1. This is the first body. In y direction, wait. Here you will be writing the position of center of mass. Wait a second. M2 body, x position of center of mass. Anyways, answer will be not changed. Answer will be same, but we have written for the same body two times. How you can do? M1 body. This is the M1 body. What is the x position of center of mass? What is the x position of center of mass? It will be 0. But for M2 body, what will be the x position of center of mass? This is the M2 body, and if you will try to calculate what is the position of center of mass, can you say this is the position of my center of mass? So what is the distance from this origin? Can I say this distance is L by 2? If the distance is L by 2, answer is not going to change. So just put the value m2, that is the identical body, into L by 2. So finally again this will get cancelled out and the final position will be coming L by 4 as the x position of center of mass. Now let's come to the y position, because I have told you that you can separate the two bodies combination into two parts, first in x direction, then in y direction. So let's see, understand for y direction now. Let's come to y direction. For y direction, m1 body, I have already told you, this is the m1 body. Where is the y center of mass? What is the y position? What is the y coordinate of the center of mass? L by 2. Simply put L by 2 plus m2. This is the m2 body. Can you tell me what is the position of the center of mass? I will say simply it is L by 2, that is the x position, and y position is nothing but 0. So simply I can say this time it will become here 0 divided by the total mass, that is 2m. So I can say again this this mm will get cancelled out and here it will become L by 4. So xcm also L by 4, ycm as well as also L by 4. Correct? समझ में आया? बहुत बढ़िया. So center of mass, I have a lot of questions different. Let's solve this kind of question. This question looking dangerous or what? Solve it. Take your time. Solve it. Try करो. क्या क्वेश्चन में बोल रखा है? 3 identical metal balls, identical है, that means masses we will assume m. Each of radius r are placed touching each other on a horizontal surface such that equilateral triangle is formed when the centers of 3 balls are joined. What is the location of their center of mass? What will be the location of their combined center of mass? 3 bodies are kept like this and all their center of mass positions are there, but for the combination of these 3 balls, what will be the center of mass position? Simply nothing we are going to do. Again we are going to apply the same kind of concept. Eitherwise you can write for xcm, ycm in different, otherwise you can do for combined also. It's up to you. Okay, so let's do for different xcm. Let's write xcm. What is the position of x center of mass? How many bodies are there? 3. What is the formula? Will be m1 x1 plus m2 x2 plus m3 x3 divided by total mass. Total mass I will say 3m. M plus m, that is 3m. It will become. Now put the position of center of mass. What is the x position of the? Let's suppose this mass is m1, this mass is m2, and this mass is m3. Correct. Now put the values. m1. What is the position? X position of first mass? 0 plus. What is the position of second body? m2, 2r plus. Again m3. All the anyways identical, but still I am putting the values. What is the position of center of mass for this body? X position. It is equals to r divided by the total mass. Total mass is equals to 3m. I can say this way is simply 0. Here it is 2m into m into 2r. Here it is m into r. That means it will become 3mr. 3mr and 3m cancel. That means what is the position? X position that is going to come as center of mass is r. Simply just we have put the values. Nothing special that we have did. Now come to the y position. How you can calculate for y position? Y center of mass. The formula. What will the formula that you will be writing? You will be writing m1 y1 plus m2 y2 plus m3 y3 divided by m1 plus m2 plus of m3. Correct? That means the total mass that will be coming is 3m. Very good. Now first mass, what is the y position that you will be writing for this? Again it will become 0 for the second mass. Second mass, what is the y position? Again this is 0. Third mass, what is the y position that here it is given? But it is root under 3r divided by the 3m. That means what is the position that is going to get? M cancel, root 3r. That means it will also get cancelled. Here it will become root under 3. That means the answer will be root under r by root 3. That is the position of ycm. That can also be written as 0.67. So we have segregated once in x direction, once in y direction, and then we have calculated the result. Clear? समझ में आया? Very good. So a lot of different variety of questions you can see. Let's suppose for this kind of body where little bit of taking element student usually feel difficult. Let's see how to solve this. Again we are going to go the conventional method. See, this kind of continuous body is there and you want to calculate the center of mass position. Okay, so a semicircular ring is there, uniform m mass is distributed. Okay, so how you can define the center of mass? Okay, this is the question. It will be again, see, Analyze this question in two directions, in x direction and in y direction. What will be the position of x center of mass? If I am saying that this position is 0, 0, in x direction, that means I will bisect this body into this half. This is the one half, this is the second half. Can I say by this point both these sides are completely identical? Both these sides are completely identical. So about x-axis, if I'm breaking this in like this way from this x-axis, I can say this side is identical, this side is identical. So can I say position of center of mass for x coordinate is 0 only? Yes or no? Because left side be equal, right side be equal, that means I can say that center of mass for the x position will be equally simply at the center point. Correct? Now you have to think only for y direction, because y direction, here it is a different mass, here it is a different mass. Positions are different from the distance, are different from the masses. So here you have to think about for y direction. Correct? Let's see for y direction what you can do. The formula will be what? Integration of y dm divided by the integration dm. Okay, the game is all about how you are writing this dm mass. Correct? See now how you will be writing that dm mass. See, what is this dm? Let's suppose I have gone at an angle theta and I have cut it out an element. I have cut it out an element. Okay, I have gone at some angle theta and I have cut it out an element. How you can write the mass of this cutted element dm? How you will be writing that mass? A small dx thickness I have that cut it out. Okay, at a d theta angle I have cut it. So what I will say simply, again the same kind of concept I am going to apply. In complete pi r distance, the total circumference is how much? 2 pi r. That means for half one, how much it will become? Pi r. And then in that pi r, I can say how much mass is concentrated? M. In that pi r, how much mass is concentrated? M. And then I can say for 1 unit, how much mass is there? For 1 unit, I can say how much mass is there? It will be m divided by pi r. For 1 unit, how much mass is there? M divided by pi r. So what I will say for this dx thickness mass, how much dx thickness length, how much mass is there? Firstly, define this dx thickness. Dx thickness, how I can write the length of an arc, radius into the angle. That means I can say for this dx thickness, I will define r d theta, and for r d theta, how you can place the mass, you will be writing r into d theta. This is the dm mass that you are going to write. This is the dm mass that you will be writing. So once you have written the dm mass, then it is very simple. Then you can easily integrate it from 0 to pi and have your answer. See, here you can integrate it simply. You have just put it y dm, and how you have written dm, m divided by pi r into r d theta. Just replace it in the equation, and here you will be writing y as r sin theta, because you can replace, you can apply the right angle triangle, you can take the component y as this perpendicular distance from the dx element is r sin theta. Just put that and integrate from 0 to pi, you will be having your answer. And the answer that you have to remember is x cum is 0, that I have already told you, and y cum will be 2r by pi. Anyways, you have to remember all the values in the exam. You are not going to derive it from the complete basics. I just wanted to tell you how to write the dm mass, okay, because that is the most important part. For good questions like for JEE main, or I will say for JEE advanced, you should be knowing how to write the dm mass. That is the important thing. And what is the limit of integration? Limit of integration is clear. This is the dx element. You have to integrate this complete circular ring. That means you will integrate it from theta is equal to 0 to complete theta is equal to pi. If you are covering this 180-degree angle, then you will be integrating this complete curve. Clear? Very good. So same way, the position of center of mass, how you have written the displacement of center of mass, you have written as r cum is equal to m1 r1 plus m2 r2 divided by summation of masses. Same way you can write for the velocity of center of mass as well. Just differentiate it. Differentiating position is going to give you velocity. So velocity equation will also be coming same. Velocity of center of mass will be m1 v1 plus m2 v2 till mn vn divided by the total mass. So if you have written for velocity, differentiate it again, can you say you will have acceleration? So acceleration equation will also be same for center of mass. Acceleration of center of mass can be written as m1 a1 plus m2 a2 plus m3 a3 till mn an divided by the total mass. Same way you can write for the acceleration as well. So now we are clear how to write the velocity, acceleration and all those kind of things. Clear? For example, there is a question. Let's try to tackle this question. What the question is saying. Figure shows two block of mass 5 kg and 2 kg based on a frictionless connected body. An external kick is given a velocity 14 meter per second to the heavier block. Here is the heavier block and you have given some kick or from anywhere the velocity is coming this 14 meter per second. Very good. Of the heavier block towards the lighter one, now it will start traveling. Deduce the velocity gained by the center of mass. What will be the center of mass velocity will be there, because now you have produced some velocity. Initially it was kept at rest, okay, no problem was there. That means center of mass was also at the rest, it will have some position. But now since you have kicked it out, that means I can say center of mass will also start shifting now. Here you can see there was some center of mass you have assumed firstly, and then now the question is asking you for the velocity of center of mass. This is what you have to do. Let's see how we can do. Velocity of center of mass can be written as m1 v1 plus m2 v2 divided by m1 plus m2. Okay, so how you can write velocity of center of mass? m1 v1, what is m1? 5 kg. What is the velocity of that body? That is equals to 14 plus m2 is how much? 2. What is the velocity of that body? It is at rest, it is not get affected, and you know the property of spring. If one body is get here, it will not get this body will not start moving until unless there is a case of maximum compression. When it will get maximum compressed, then it will start moving. That the concept in Newton's law we already know. And what is the total mass of the system? It is nothing but 7. This will get cancelled, that means 5 into 2. The velocity of center of mass will be how much? 10 meter per second. With 10 meter per second, now the center of mass moving in forward direction. See how beautiful this is. There are two bodies that are separately moving with a different velocity, but your center of mass is moving with some different velocity. That is the beauty of this concept of center of mass. Okay, and we always analyze any combined system with the center of mass. Okay, so I hope that you have loved this much. A lot of varieties of questions are made in this topic. If you will see the next variety of questions what you will be having. Whenever the external force is 0, in Newton's law lecture also I have discussed about it a little bit. Whenever external force is 0, what is force? Rate of change of momentum by time. That means what I can say, what about the change of momentum? That it is equals to 0. Change momentum is equals to 0. That's why we have proved that it okay. Momentum was conserved. Now understand here, if I am saying that the same thing in a different manner little bit, if net force is equals to 0, net applied force is equals to 0, that is what I can say, acceleration is equals to 0. If acceleration is 0, about center of mass I am saying, if acceleration of center of mass is 0, what I can say about the velocity of center of mass, that it is going to be constant. And one very important line is there that can solve a number of questions, a single statement. Applications are wide, that if initially center of mass was at rest, and there is no external force applied, then finally also center of mass will be at rest anyhow possible, if and only if external force is not equals to 0. This is what you have to understand. And on this single line, if I will tell you, where you will be entering into the number of questions are there that you can solve from the single concept, that change in position will become 0. Change in position for the center of mass will become 0, because initially if it was at rest, finally also it will be at rest. I will be also having some questions, but I've told you, from after watching this lecture, you have to go from your end, you have to solve numerous number of questions. Okay, then only you will be understanding. See this example. What this example is, Mr. Verma, a person is there, M1, 50 kg, Mr. Verma is there, and Mr. Mathur is there on the second side. Okay, Mr. Verma and Mathur are there, they are standing on a boat on two extremes of 4-meter long boat. 4-meter long boat is there, and they are just standing on the other end of the boat. And boat mass is also given, that is equal to 40 kg. Okay, standing still in water. To discuss mechanics problem, they come to middle of the boat, neglecting water resistance. How far the boat move on the water during this process? All of a sudden they have this curiosity to discuss some mechanics problem. Okay, they got some interest in mechanics all of a sudden, and they decided that they will meet at the center point of the board, and then they will going to discuss this problem. So due to their motion neglecting the water resistance, we are going to assume ideal condition. What will be the displacement of the boat that you have to calculate? What will be the displacement of the boat that you have to calculate? Let's see how to solve this question. Let's understand how to solve this question. See, we will assume now, let's suppose the displacement of center of mass, initially center of mass will be at rest, everything was at initially center of mass will be at, the persons are moving, that means that is an internal scenario, that is not an external force that is applied. That means can you say finally also center of mass have to be at rest, correct? Fine, I will say that let's suppose this boat has displaced by some distance d, this boat has displaced by some distance d, correct? This person have moved to distance how much? 2 meter is the exactly center of mass where it will be lying halfway. That means how much a net distance it will be traveling. Can I say 2 meter? Obviously it is going to travel, but this body, this what I can say, the boat, actually the boat is also moving in the forward direction by how much distance d. So can I say the net displacement for this person, Mr. Verma is 2 plus d, correct? Mr. Verma kitna chal raha hai? 2 plus d. So what will be the distance or the position that will be changed for Mr. Mathur? For Mr. Mathur, can I say 2 he is going to travel, but can I say he is also displaced in the backward direction again by a distance d. So net displacement is 2 minus d. इतना समझ में आता है? इतना समझ में आता है? अगर इतना समझ में आता है तो you are done. That's it. That is what you have to do. Now just there is a formula that you have to how to calculate that d. What you will be writing? X position, center of mass. What is the position of center of mass? You will be writing m1 x1 plus m2 x2 plus m3 x3 divided by the total mass m1 plus m2 plus m3, correct? And what is the position of center of mass? It is, I can say that if initially center of mass was at rest, that means the displacement in the center of mass position will be 0. That means what is the value of this thing? It is 0. That means I can say total, in total I will say m1 x1 plus m2 x2 plus of m3 x3 is equals to 0. That's it. Now just put the values. Now it's about the values. M1, let's suppose for the boat, if you are writing M1, right? What is the mass of the boat? 40. Now what is the displacement for the boat? I will write d. Distance here, the displacement for the boat was. Now further M2, who is written as M2? That this 50 kg person. What is the net displacement for this 50 kg person? It was equals to 2 plus d plus. Now M3 is the Mr. Mathur. What is the weight of Mr. Mathur? 60. And what I will write about the displacement? You will write 2 minus d, but better be careful that it is moving in negative direction and you are writing displacement. That means you have to apply a negative sign as well here, correct? Now solve it. Here you will be having 40d plus of 100 plus of 50d minus of 120 plus of 60d, correct? Now what you will be getting here? On the other side, when you will take it, it will become minus of 20. Here it will become plus of 20. Here it will become 90 plus 60, that means 150d. It will get cancelled. D will be equals to 2 divided by 15 meter. So what is the displacement of the boat that you will be having? That boat will be displaced by a distance of 2 divided by 15 meter. So how the boat is going to displace. So what is the concept that we have applied? Again, if I will summarize, this is a very good example of the concept that if initially center of mass was at rest, finally also it will be at rest. That means I can write simply that x cm, the change in position of the center of mass, is equals to 0. Simply I can write that, correct? Very good. Conservation of momentum, already I have told you, whenever the external force is 0, you have to conserve the momentum. Okay. For example, let's have some questions on the concept of conservation of momentum. A bullet of mass 10 kg is moving with velocity 300 meter per second, hits a block of steel of mass 5 kg. Here the block is having mass of 5 kg and drops dead and get it embedded into it, and it's not coming out of that body. The velocity of the block that will be attained. What is the mass? 5 kg. What is the mass of bullet? It is equals to 10 gram. How you will be writing the equation? Can you say in this complete system, whatever has happened, any external force is there? No. A bullet is there, it got embedded into it. That means all these things are internal. So can you say if external force is equals to the momentum have to be conserved? If momentum have to be conserved, what I can say, beta? here I will say initial momentum. What I can say, initial momentum, mass of the bullet into velocity of bullet initially. And can you say this body was initially at rest, that means there is no momentum for this body. Finally what you will say, that this body, both these will get embedded into it, that means mass of block plus mass of bullet, they are moving with a common velocity that is represented as Vs. That is represented as Vs, and exactly that Vs velocity of the system you have to calculate. So Vs you can write mb, mass of bullet, that is 0.001 kg divided by 1000, that means 0.01 kg, not 001 kg, divided and multiplied by the velocity. How much the velocity was there for this bullet? It is equals to 300 meter per second, divided by, now what is the mass of block? 5 kg, and what is the mass of bullet? 10 gram. That means can you say it is nearly negligible in as compared to 5 kg. That means simply I will write here 5. What is the result that I can say? Here it will become 3 divided by 5 meter per second. 3 divided by 5 meter per second, or in terms of centimeter per second, if you want to calculate it, you can multiply it by 100. It will be 20. Answer will be 60 centimeter per second. In terms of centimeter per second, if you want to calculate, it will be 60 centimeter per second. It will be the combined velocity of the block and the bullet. Clear? So this is the question that has been solved on the concept of conservation of momentum. Clear? Very good. Let's move further. Here, what is the question? See, a bullet of mass 80 gram is fired by a gun of mass 100 kg. Mass of gun is given 100 kg. A bullet of mass 200 gram is fired from here. If the muzzle velocity of the shell is 80 meter per second, calculate the recoil velocity of the gun. What will be the recoil velocity of the gun? Again I will say the simply, when gun was at rest, nothing was moving, that means center of mass was at rest. Now if you are firing anything, that means this bullet is coming outside in the forward direction, that means if it is having some momentum in the forward direction, this body will be feeling some can I say recoil velocity in the backward direction. From the basic classes we are understanding this. And how we solve this kind of questions? Using the concept of momentum conservation. So let's see what is the concept of momentum conservation. How you can apply this in this kind of questions? I can say initially momentum is equals to 0, that means it should be finally also 0. Finally, how you can write the momentum? I will be simply writing final momentum, mass of bullet into velocity of bullet, not plus I will write, because this velocity is in negative direction, and I know that if I am writing a vector quantity, I have to represent it with a negative sign. So what I will be writing, mass of the gun into velocity of the gun, and it is going to be equals to 0. And exactly what I have to calculate, the velocity of the gun. Now just solve it. Velocity of gun will be equals to, what is the mass of bullet? Mass of bullet, the value that you have taken is 200 gram, that is 0.2 into velocity of bullet. Velocity of bullet is 80 divided by the mass of the gun. Mass of the gun, how much you have taken? It is equals to 100. This is what you will be having the values in meter per second. If you want to convert into centimeter per second, multiplied by 100, 100 cancel, it will be how much? 16 centimeter per second. It will be equals to 16 centimeter per second. Is it clear? समझ में आ रहा है कैसे how we are applying this concept of momentum conservation for different variety of questions. And numerous varieties are there for momentum conservation. Numerous varieties are there that you can apply. Next thing is impulse. Impulse I have discussed. Okay, so I am not giving much time to impulse. Impulse I have directly told you that it is nothing but change in momentum. In Newton's law also I have explained you impulse in the last to last lecture. If you will be going for this same marathon revision series, there we have discussed about impulse. So what is the formula for impulse? Simply change in momentum. Either you can calculate, or if a ft curve is given, just simply calculate the area under that ft curve. You will be getting the impulse. Okay, both these methods we have discussed. Even we have calculated there also. So let's have some basic question on that, so that you can have the idea of impulse. A player takes 0.1 second in catching a ball of mass 150 gram moving with a velocity 20 meter per second. The force imparted by the ball on the hands of the player. You have to calculate what is the force that is applied whenever a player is there. Let's suppose here is a ball. If I am catching this ball, oh shit, I was not able to catch the ball. If I am catching this ball, what I can say that some impulse is acting on my on my hand, and let's suppose if it is recoiling some, that means it will require some time also. It is hitting some for some moment, it was in contact. So what is the force that will be imparted on my hands? What is the force imparted on my hand? Obviously you know, those people who have played cricket, sometimes balls hit very hard in the hand. Okay, so why that is coming? Because of the change in momentum. You are catching that ball, you are stopping that momentum is converted into force, because we know the relation between them, your force and momentum. That force is equal to rate of change of momentum, correct? So let's understand how you can define what is the force that will be applied here. See, force is equals to dp by dt, correct? That is what I can say, final momentum minus of initial momentum divided by time. And guys, if you have catched it, that means what is the final momentum? 0. Finally you are catching that thing. Now what you'll be writing about the initial momentum? Let's so there is some urgent work. We will be continuing after just after some time. Okay, we'll be continuing from the same question. Okay, till then just try to solve it, and we'll be continuing from the same position. Okay, so till then keep learning, keep going with Tapasya. See you very soon. Okay.